See, moment of inertia of thin ring about transverse axis passing through center. About transverse axis passing through center means the axis is perpendicular to the ring. Okay, axis is perpendicular to the ring. It's like this. Suppose this is the ring. I have a ring. Okay, we have to find moment of inertia of this ring. Please look at the screen, children. We have to find moment of inertia of this ring. Okay, and this is the axis, transverse axis. It passes through center of the ring. Now we are going to find moment of inertia about this axis. Okay. For this, we'll consider a thin ring. Let m be the mass of the ring, r be the radius of the ring, and c is the center of the ring. Okay, and this ring is rotating about an axis passing through its center. It's rotating like this. This ring is rotating like this. Okay, and perpendicular to its plane. So this axis is perpendicular to the plane. You can see this is the axis. This is perpendicular to the plane, and it is passing through the center. देखो यूनिफॉर्म रॉड में हमने क्या किया था? यूनिफॉर्म रॉड में वी हैड कंसिडर्ड अ स्मॉल एलिमेंट dx. ठीक है, एंड वी हैड फाउंड आउट द मोमेंट ऑफ इनर्शिया फॉर दैट स्मॉल एलिमेंट अबाउट दैट एक्सिस. In the same way, here in the ring, we can consider a small element. Anywhere on the ring, we can consider a small element. This small element we can consider. This small element we can consider. Anywhere you can consider a small element on the ring. Okay, we will find moment of inertia of that small element about that axis first, and then we'll integrate to get the total moment of inertia. This is what we are going to do. It's very easy. ठीक है, पहले एक के अबाउट मोमेंट ऑफ इनर्शिया निकालेंगे, छोटे से एलिमेंट के अबाउट, फिर जितने छोटे छोटे एलिमेंट्स को सब इंटीग्रेट करोगे देन यू विल गेट द रिंग. ठीक है, तो अब this small element is a part of the circumference of the ring, we can say, and on integration we'll get the circumference only. No, and if we assume that there is uniform mass distribution, if there is uniform mass distribution, in this case also we are going to find mass per unit length. But here length of the ring is the circumference of the ring, right? It's 2 pi r. So mass per unit length is m upon 2 pi r. Are you getting what I'm saying? Easy है ना? बस यही करना है हमने. सेम कॉन्सेप्ट लगेगा, सब कुछ सेम लगेगा, बट आपने रिंग का जो लेंथ है उसको 2 pi r लेना है. ठीक है, so let's write first circumference और length of the ring. Length or circumference of the ring. This is 2 pi r. 2 pi capital R, because we are assuming that r is the radius of the ring. ठीक है, now we can find mass per unit length of the ring. Mass per unit length of the ring. Mass is m, so mass per unit length of the ring is m upon 2 pi r. ठीक है, now we'll consider a small element on the ring. Consider a small element of length dx on the ring. Okay. Now see, mass of that small element. We can find mass of the element now. So mass of the element. If you are considering here the small element dx, this is the small element dx on the ring. So mass of this element is dm. Okay, so mass of this element is dm, and dm is equal to mass per unit length multiplied by dx. This is how we can find mass of the small element that we had taken. Okay, now we will find moment of inertia because of this small element about this axis. Okay, so it is at distance r from the axis of rotation. This small element m is at distance r from the axis of rotation. So we can write integration, not integration, sorry. We can write dm. This is the mass of the element and square of the distance from the axis of rotation. We can write like this. In place of dm, we can write m upon 2 pi r dx into r square. Okay, this is the small moment of inertia because of this small element. Now we can find total moment of inertia by integrating this. Can you please tell me the limits of integration? Simplify this first. You'll get m r upon 2 pi into dx. Now tell me the limits of integration. How are we integrating? See, this is the small element. We can start from here. So from 0 to, along the circumference of the circle, length becomes 2 pi r. If we come back to the initial point from where we have started, so 0 to 2 pi r we can take. Okay, so this is the limit. 0 to 2 pi r, because all the dx elements are on the ring only. So we'll integrate it from m upon 0 to 2 pi r. Okay, now we'll get mr upon 2 pi. We can write this outside the bracket, and outside the integration, and here in the integration we have just dx and the limits. And when we integrate dx, we get x. Okay, on integrating dx, we get x. So mr upon 2 pi, bracket में क्या लिखोगे x. Now write the lower limit and the upper limit. Now we'll put upper limit first. Minus lower limit. ठीक है? On solving this, you will get mr square. 2 pi cancel हो जाएगा. Okay, now we have applications based on this. Moment of inertia of thin ring about a diameter. As we know, moment of inertia about the axis which passes through the center of the ring. Okay, and you can see that here Iz is the moment of inertia of the ring about z-axis and passes through the center of mass of the ring and perpendicular to the plane. This we have just found out. It's mr square. Okay, and similarly we can find moment of inertia about any diameter. How many diameters do we have in a ring? How many diameters we can draw? We can draw n number of diameters, infinite diameters. No, बहुत सारे diameters हम draw कर सकते हैं, right? So as many diameters as we want. So we are considering only the diameters which passes through x and y axis. Okay, we are considering two diameters only which can pass through, which one diameter is passing through x axis and other diameter is passing through y axis, on y axis. Okay, so these two diameters we are taking, and we are going to find moment of inertia about these axes. So you can see that here we have three axes, and all these three axes are mutually perpendicular to each other, right? So which theorem goes well in this, Vinam? Any idea? Which theorem should we apply here, parallel or perpendicular?
Ma'am, perpendicular.
Yes, perpendicular theorem. We are going to apply perpendicular theorem, and we can say that Iz is equal to Ix plus Iy. Now we can see both the Ix and Iy, they are along the diameters. So they are equal, okay? Ix and Iy are equal because they are along the diameters. So using perpendicular axis theorem, we can write Iz is equal to Ix plus Iy. And Iz is the moment of inertia along z-axis, and it is the same moment of inertia where we, pass the axis through the center of mass, because here center of mass lies at the center of the ring. And you can see that there is, it lies outside the ring. Center of mass lies here at the center of the ring, outside the ring. ये हमने पढ़ा था ना कि जरूरी नहीं है कि सेंटर ऑफ मास वही होगा जहां एक्चुअल में कुछ है ना? ठीक है, तो और Ix Iy का मोमेंट ऑफ इनर्शिया इक्वल होगा, राइट? सो इन प्लेस ऑफ Ix Iy वी कैन राइट जस्ट Ix और Iy. So we can write 2Ix, either 2Ix or 2Iy. So in this way we can get the moment of inertia along the diameter as this. Okay, Iz is mr square. Put this value here and you'll get the moment of inertia along the diameter as mr square by 2. Easy. We have just applied perpendicular axis theorem here. Okay, because we know the formula now, we can apply. We can use it. Now we have to find moment of inertia of a ring about a tangent in its plane. So tangent lie in the plane where the ring is. Okay. So how will you find moment of inertia? C is the center of the ring, and this Iz, it is passing through the center of mass of the ring. So we can also find moment of inertia. We have just found out the moment of inertia, of the ring about the diameter. Now we have a tangent, okay, which is passing through point O. And this tangent lies in the plane of the ring. So this tangent is parallel to the diameter or the perpendicular that we had drawn through center of mass. Tell me. This tangent is parallel to the diameter which we have drawn, right? This tangent is parallel to the diameter. So we can apply parallel axis theorem here. Apply parallel axis theorem. So tangent is parallel to the diameter of the ring, and I naught is the moment of inertia of the ring about a tangential axis passing through point O. Because this is passing through point O, so we have assumed that let consider the moment of inertia passing through O as I naught. We can write IO, okay? And it is in the plane of the ring, and distance between the two axes is equal to the radius of the ring, which is R. So we can apply parallel axis theorem, right? Now tell me moment of inertia about the axis which passes through the center, and it is the diameter. Then moment of inertia is mr square by 2, right? Right? So moment of inertia is mr square by 2. So IC is mr square by 2, and just put the values here. It's mr square by 2 plus mr square. है ना? So answer is 3 by 2 mr square. देखो, look at the cursor. About this axis, moment of inertia is mr square by 2. Diameter के about है mr square by 2. And this axis is passing through the center of mass, through the center of the ring. Okay, and this axis is the axis about which we have to find the value of I. Okay, अब ये इसके अबाउट हमने मोमेंट ऑफ इनर्शिया फाइंड करना है. इसका हमें गिवन है, तो जिसका गिवन है मोमेंट ऑफ इनर्शिया वो प्लस मास ऑफ द रिंग एंड डिस्टेंस बिटवीन द टू एक्सिस, स्क्वायर ऑफ द डिस्टेंस बिटवीन द टू एक्सिस इज आर स्क्वायर. ठीक है, वही किया है, तो इसका हाफ एम आर स्क्वायर प्लस एम आर स्क्वायर इज 3 by 2 एम आर स्क्वायर. इजी. देखो, what if I want to find moment of inertia about an axis which is perpendicular to the plane and tangent also. Suppose I want to find, let's consider this point as C, moment of inertia about a tangent perpendicular to the plane. So for this, draw a ring. Okay. Now we know the moment of inertia about an axis which passes through the center of the ring, right? About this axis, we know the moment of inertia. And we have to find moment of inertia about this tangent. Yes. So moment of inertia about a tangent perpendicular to the plane. See, this tangent is also, this is also a tangent because it touches the ring at just one point. But this tangent is not in the plane of the ring. Rather, this tangent is perpendicular to the plane of the ring. Okay, because we know the moment of inertia about this axis, right? It is mr square. We have to find moment of inertia about this axis. We can write IT, T for tangent. Okay, so IT is equal to I, let this be ICM, because it is passing through the center of mass of the ring, okay, plus mass of the ring, and square of the distance between these two is r square. So ICM is mr square plus mr square, and your answer is 2mr square. Yes, please read the question first. A circular ring is rotating about an axis passing through its diameter. if its radius of gyration is 10 centimeter, diameter of the ring is, and these are your options. We have a ring, it is rotating about an axis passing through the diameter. Okay, and if radius of gyration is given, it is 10 centimeter, we have to find the diameter of the ring. See, if an axis is passing through the diameter and it is rotating about that axis, then we can find moment of inertia about the diameter, okay? And moment of inertia of the ring about its diameter is mr square by 2. So we know the formula. Radius of gyration is given, it's 10 centimeter, we have to find diameter of the ring. How will we do this question?
3.
See, radius of gyration is given, so we can write moment of inertia as mk square also, no? We can use the relation mk square, okay? Moment of inertia is mk square, we can write. On comparing the two, you'll get k square as r square by 2. And k is r by root 2. Value of k is given, it is 10 centimeters, so r is 10 root 2. Because radius is 10 root 2 and therefore diameter is twice of radius, it is 20 root 2 centimeter. Now let's move to the next question. These are the options. Two rings of the same radius and mass are placed such that two rings of the same radius and mass are placed such that their center are at common point and their planes are perpendicular to each other. The moment of inertia of the system about an axis passing through the center and perpendicular to the plane of one of the rings is. Mass of the ring is given, radius is given, and options are also given. You have to find the correct option out of these four. So we have two rings, they have the same radius, they have the same mass, and their center are at the common point, and their planes are perpendicular to each other. The rings are placed perpendicular to each other, and we have to find moment of inertia of the system about an axis passing through the center and perpendicular to the plane of one of the rings. Choose any ring and find the moment of inertia about that ring. I hope the question is clear. Yashika, is the question clear? Vinamr, Ameha, question? No?
I'm clear question.
Question clear. Okay. Now look at this. We have two rings here, and these two rings are placed perpendicular to each other. Their centers are coinciding. Both have the same mass and the same radius. Their centers are coinciding, and they are placed perpendicular to each other. Now we have to find moment of inertia about an axis passing through the center and perpendicular to the plane of one of the rings. किसी भी एक रिंग के प्लेन के परपेंडिकुलर और सेंटर से पास करना चाहिए, तो उसका मोमेंट ऑफ इनर्शिया आप कैसे फाइंड करोगे? See, for one, axis is perpendicular to the plane and passing through center of mass. So we can take moment of inertia of first ring as mr square, है ना? And for second axis, it is along the diameter. I think there is doubt in this question. You can ask me if you have any. देखो, आपकी जो ये वाली रिंग है, look at the cursor movement. ये वाली रिंग है. We are considering this axis. ठीक है? तो इसमें क्या था कि किसी भी एक रिंग के सेंटर से पास होनी चाहिए एक्सिस और उस रिंग के परपेंडिकुलर होनी चाहिए उसके प्लेन के. तो अगर हम फर्स्ट रिंग कंसिडर कर रहे हैं तो ये वाली जो एक्सिस है, ये जो डार्क लाइन है, सॉलिड लाइन, यू कैन सी जो डायमीटर बनाया हुआ है हमने, ये जो डायमीटर है ये फर्स्ट रिंग के सेंटर से पास कर रहा है और ये फर्स्ट रिंग के परपेंडिकुलर भी है. ठीक है, तो अगर हमें फर्स्ट रिंग का मोमेंट ऑफ इनर्शिया फाइंड करना है तो उसके लिए ये एक्सिस परपेंडिकुलर है और सेंटर से पास कर रही है, तो वी कैन राइट mr स्क्वायर फॉर दिस. और अगर हमें सेकेंड रिंग के लिए मोमेंट ऑफ इनर्शिया फाइंड करना है तो सेकेंड रिंग के लिए यू कैन सी ये इसके डायमीटर के अबाउट है ना। ये जो एक्सिस है द सेम सॉलिड लाइन जो फर्स्ट रिंग के लिए परपेंडिकुलर है वो सेकेंड रिंग के लिए क्या है, उसका डायमीटर है। तो डायमीटर के अबाउट भी मोमेंट ऑफ इनर्शिया हमें पता ही है ना, क्या होता है, m r²/2 होता है ना। बस यही करना है, दोनों की मोमेंट ऑफ इनर्शिया को ऐड करके यू विल गेट द आंसर। वाज इट डिफिकल्ट? इजी था ना, कुछ भी नहीं था इसके अंदर, ऐसे बस इतना सा इतना बड़ा क्वेश्चन लिखा हुआ था, छोटा सा आंसर है ना। एक्सेप्ट करो, स्माइल होनी चाहिए फेस पे हमें, हाँ। ठीक है, ओके, लेट्स मूव टू द नेक्स्ट क्वेश्चन नाउ। We have a thin rod we have done already, right? So we have a thin rod of mass m and length l. It is bent into a circular ring, मतलब हमने rod की ring बना दी है. The expression for moment of inertia of ring about an axis passing through its diameter is, these are your options. Vinam, please turn on the camera. Keep your camera on, बच्चे. Mass is m, length is l, ठीक है? Rod is given, mass is given, length is given, and we have, bent the rod in the form of a ring. And we have to find moment of inertia about the diameter. See, length of the rod and circumference of the ring are equal. है ना, क्योंकि जो रॉड है उसी का ही तो रिंग बना है, तो सर्कमफरेंस इक्वल होगा, तो L इज इक्वल टू 2πr. सो फ्रॉम हियर वी कैन फाइंड R. R क्या आएगा, L अपॉन 2π. Yes, R is L upon 2π. Now, because about the diameter, when we find moment of inertia about diameter, then formula is m_r²/2. Okay, we'll just put the value of R here. It's L/2π. So L²/4π² हो जाएगा. And solve this. On simplifying, you'll get your answer. mL²/8π² is the correct option. Easy था ना ये भी? Should I move to the next question? Should I move to the next? You're writing? देखो ये प्लेट है and this is ring. Mass of the plate is m, radius of the plate is r, and moment of inertia of a thin circular plate about its natural axis. So this is the natural axis. It passes through the center and perpendicular to the plane, and moment of inertia about this axis is mr²/2. We have to find moment of inertia of a circular ring whose mass is half the mass of the plate, means its mass is m/2, and radius is twice the radius of the plate. Radius is 2r. About an axis passing through any tangent of the ring in its plane. So about the diameter, it is mr²/2 for a ring, right? So we have to find the moment of inertia about the tangent. Let this be AB. ठीक है, तो अब आपका जो I है, your I is mr²/2. This is for plate. It is given to you कि ये आपका I है, ठीक है। आपको किसके अबाउट निकालना है, इसके अबाउट निकालना है। तो moment of inertia about this axis AB is equal to moment of inertia which passes which is along the diameter about its diameter, वो हो गया m r²/2 plus the distance, ठीक है। तो mass और radius different है, we can write m dash r dash, and m dash is the mass and square of the distance, ठीक है। अब इसमें आप m dash के प्लेस पे पुट करोगे m/2 और r डैश के प्लेस पे पुट करोगे 2r होल स्क्वायर अपॉन 2 प्लस m/2 r डैश स्क्वायर मतलब 2r होल स्क्वायर, ठीक है। नाउ सॉल्व दिस। आपका ऊपर आ गया 4, नीचे भी 4 है, तो mr² और यहाँ पे आपका आएगा 2 mr², राइट। दिस इज 3 mr² और वी कैन राइट दिस एज 3 इंटू 3/2 mr²/, सॉरी 2 mr², ठीक है। तो आपका जो 3 mr²/2 है, 3 mr² 2 है, 2 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 mr² 2 है एक मिनट इसको 2 से डिवाइड और मल्टीप्लाई कर दो यहाँ पे, तो आपके पास आंसर आ जाएगा। mr²/2 के प्लेस पे वी कैन राइट आई। ठीक है, तो 6 into I इज द आंसर। हाँ जी, प्लीज लुक एट दिस डायग्राम। आई होप दिस क्वेश्चन इज क्लियर नाउ। ठीक है, तो ये आपका mr²/2 हो गया। दिस डिस्टेंस इज गिवन, इट इज 2r/3। ठीक है, 2r/3 का स्क्वायर करोगे तो 4r² by 81 हो जाएगा यहाँ पे। सॉल्व करोगे एंड यूल गेट योर आंसर।